Around here, I was just studying some Tesla patents, and Nikola Tesla, you all know him, he had something called the Radiant Energy Aerial, and he built it, a large one, and this man, whose name I can't pronounce, Jess, did his version of the Tesla Aerial, made it a little smaller, and this is the circuit he built that I have copied, and I made a toy version for myself. And this toy version is over here. Here is the circuit in question. It's the aerial circuit. It's merely an antenna, which is just a piece of garbage metal attached by house wiring. I've only used the ground. And the house wiring is, I got it wound all over the place because I plan on putting this outside with a bigger antenna. The house wiring acts as an antenna, being split between two small capacitors, being rectified into positive and negative with diodes, and some large capacitors to store energy. And at last all this comes out this big ground wire. And I have the ground attached to the earth ground, which is this plug over here. What I did was I took this plug and I stripped off the outer wires and only kept the grounding part. So only the ground is connected here. So I have a complete circuit as described by Tesla. And I know everyone out there is quite the skeptic, so I'll just show you that underneath my board there's no batteries or magnets or anything. Okay. Okay. So my aerial here just sits there and collects energy out of the air. It's sensitive to radio frequency waves. So what I'm going to do right here is touch my positive and negative contacts together to discharge my capacitors. And let's see. You can see that I'm at 0 voltage right now. I'm going to let my wires separate, and the voltage starts coming up all by itself out of the air. It's catching radio frequency from my CFL bulbs, obviously. I say obviously because I'll show you some escalating voltage in a second. And this keeps, it vacillates a little bit. I should say oscillate. People vacillate. And it will go up as high as 40 millivolts, just sitting here in the basement. And this antenna is supposed to be as high as possible, and I am down here amongst my cinder blocks. But something interesting here, though. You can see this millivoltage is flattened out here. It won't go much farther than this right now. It won't go above 40 millivolts. Now watch this. I've got to take my antenna, if I can without dumping everything here. Take my antenna and put it near a CFL bulb. I'm holding it with my hand. It's not insulated. I'm wearing sneakers, so I'm insulated from the ground. And just getting that close to a CFL bulb really gets the micro voltage going. I was thinking it farther up there now. So you can tell it really goes spasmo. And I can get up to 1.5 volts this way, just off the radio frequency coming off these light bulbs. Although that seems to be about as high as I'm going to get right now. Let me try covering the whole thing up with the whole antenna here. Nope, looks like about as far as I'm going to go, but it's pretty interesting. This little toy circuit can pick up half a volt from just being close to this light bulb. So that's pretty tricky. And my meter's bugging out on me. And it takes a while for the voltage to drop out of these capacitors too. Pretty interesting, eh? So that's my story. I'll be making a larger antenna and putting it higher in the air and see what I can pick up. Tesla. Guy knew what he was doing.